Hello everybody, now we're going to solve equations with variables and constants on both sides, and by both sides I mean both sides of that equal sign. Okay, so check this out. We've got a variable and a coefficient there. We've got a constant term, I'll do that in a different color there, and we've also got a constant term there. So I have a constant term on the left side and I have a constant term on the right side. You want to collect your variables on one side, it doesn't matter which side, and you want to collect your constant terms on the opposite side. So I want to move this 8 to the right-hand side. Now if I move the negative 13, I've just moved everything to the left-hand side of that equal sign. That's not helpful. So I want to move the 8. So I'm going to subtract 8 from both sides of the equal sign. That created 0 right there. I'm left with 7x on the left, and I've got negative 21 on the right. And now we can divide both sides by 7 to solve for our variable. X is equal to negative 3. And again, if you want to check your work, you're always welcome to check it. 7 times negative 3 plus 8 equals negative 13. So 7 times negative 3 is negative 21. Whenever I add negative 21 and a positive 8, I get negative 13. So it works. This is my answer. All right, same thing is going on here. I have variable term right there. I've got constant term right there and right there. I'm going to place all of my constants on the right-hand side. I'm going to leave my variable term on the left-hand side. So this time I need to add 9 to both sides. And I'm left with 8y on the left. 31 plus 9 is 40. And now I divide both sides by 8. And I get that y is equal to 5. And again, check your work. So 8 times 5 minus 9, does that equal 31? 40 minus 9. 40 minus 9 is 31, and 31 equals 31, so that works. All right, so let's take a look at this one. We have variable terms on both sides of the equal sign. So look at this. Here's a variable term, here's a variable term, here's a constant term. So I have two variable terms. They're on opposite sides of the equal sign, and I need to get them on the same side of the equal sign. If I subtract 9x from both sides, I've just moved my variable and my constant to the same side of the equal sign. Again, not helpful. So I would subtract 8x from both sides. That creates 0 right there. Now I have my variables on the left, I've got my constants on the right, and it should make it pretty easy to solve. So 9x minus 8x is just plain old x, or 1x. And I've got negative 6 left over here. So that's that answer. Again, if you want to check your work, that's cool. Do it. 9 times negative 6, does that equal 8 times negative 6 minus 6? 9 times negative 6 is negative 54. Negative 48 here, minus 6. And negative 48 minus 6 is negative 54. So that works. Okay, so look at this one. We have variables here and here. I've got constants here. That's it. That's my only constant. So I want to put my constants on one side and I want to put my variables on the other side. So it's best if I just leave that constant alone and move my variables. So I'm going to move this 5y to the right-hand side to get it away from that constant. It's like it has cooties or something. So now I'm left with negative 9 on the left. 8y minus 5y is 3y. And now I divide both sides by 3. And I get negative 9 divided by 3 is negative 3 equals y. And to check my work, I would take that negative 3 and put it everywhere I see y. 5 times negative 3 minus 9. Does that equal 8 times negative 3? I've got negative 15 minus 9. What's 8 times negative 3? It's negative 24. Negative 15 minus 9 is negative 24. So yeah, that's my solution right there. Y does equal negative 3. Okay, on this problem, here's my variable term, constant term. So again, I want to get my variables on the same side of the equal sign. I would add x to both sides to get rid of that right there, get it away from the constant term. 12x plus x is 13x. And then I would divide both sides by 13. And to check my work, I would do 12 times 2. Does that equal negative 2 plus 26? 12 times 2 is 24. Negative 2 plus 26 is 24, so I know that's my answer. Okay, so this is a page that you might want to hit pause and just kind of read through and take some notes if you want to take some notes, but just read through it and understand it, and if you have any questions, send me a message. All right, so what that last page says is that you need to pick a side that's going to be your variable side. You need to pick a side that's going to be your constant side. So check this out. Okay, I've got 7x. There's my variable term. There's a variable term. Here's a constant term. Here's a constant term. So now you might be asking yourself, well, which side should I put my variables on? Which side should I put my constants on? Here's my rule of thumb. This is not the only way to do the problem. It's just my favorite way. I always move my smallest variable. So in this case, 6x is smaller than 7x, so I'm going to move 6x. And the reason I do that is because I like to avoid negatives in front of my variables if I can. Sometimes it's not possible, but in this case, it is avoidable. So I'm going to do that. I'm going to move my 6x. I'm going to subtract it from the right side and from the left side. That creates 0. 7x minus 6x is 1x or x. I'm going to bring that straight down. I'm going to bring this straight down. And now I would subtract 5 from both sides. So x is equal to, what's 2 minus 5? It's negative 3. Again, you can check your work by taking that negative 3 and putting it everywhere you see x. 7 times negative 3 plus 5 equals 6 times negative 3 plus 2. And I'm going to put a question mark there because I'm checking this. I don't know for sure that it works, so I want to make sure. Negative 21 plus 5, does that equal negative 18 plus 2? Negative 21 plus 5 is negative 16. Negative 18 plus 2 is also negative 16, so I know that's my answer. All right, so on this problem, notice you have variables here and here. I also have constant terms here and here. So I would grab, again, my smaller variable term and I would move it to my larger one, hoping that I could get rid of a negative sign. And in this case, it does work out nicely. So adding 2n to both sides. Notice how I put that 2n underneath its like term. I'm not going to put it under the constants because constant terms and variable terms are not like terms. 8n plus 2n is 10n. I'm going to bring this straight down. Eventually you'll start doing this in the same step, but for now, while we're just learning, we're going to keep it in separate steps. Now I want to move my constant terms over to the right side because I chose my left to be the variable and my right to be the constants. So I've got 10n is equal to 10. Divide both sides by 10. You get that n is equal to 1. And again, to check your work, 8 times 1 minus 4, does that equal negative 2 times 1 plus 6? 8 minus 4, does that equal negative 2 plus 6? 8 minus 4 is 4. Negative 2 plus 6 is also 4. This is my answer. Okay, we're still practicing with having variables and constants on both sides. Here's my variable term, here's my variable term, here's my constant term, here's my constant term. And like I said, I've been saying this all along, I grab my smaller variable term and move it to my larger one, hoping to avoid a negative number. And this one, it works out pretty nice too. Out of 7a and 13a, 7a is smaller. So I'm going to move that one. I'm going to subtract 7a from both sides of the equal sign. That creates 0. I'm going to bring this straight down. 13a minus 7a is 6a, and I'm going to bring this straight down. Now I'm going to move my constants to the same side. I'm going to put my constants on the left this time. Negative 3 minus 7 is negative 10. And now I divide both sides by 6. And so I get that negative 5/3 is equal to a. And I like negative 5/3, but if you were to give me an answer of negative 1 2/3, I'd also take that answer. I honestly prefer that you not give me the decimal here because this decimal is a repeating decimal. I don't want to see 0.6666666, okay? So don't give me that. Give me either negative 5/3 or negative 1 2/3. And again, you can check your work. If I were checking my work, I want to use this one. It's so much easier to check with a mixed number than with an improper fraction than it is with a mixed number. I think, again, personal preference. So 7 times negative 5/3 minus 3, does that equal 13 times negative 5/3 plus 7? So, you know what? Because I can't stand dealing with fractions sometimes either. So what I would do is I would grab my calculator. 7 times negative 5/3 minus 3, and I get an answer of negative 14 2/3. And now on the right-hand side, I get 13 times negative 5/3 plus 7, and I get negative 14 2/3. And that's exactly what I was hoping for. So I know for sure this is my answer. All right, so take a look at this hot mess. Here's a variable term, here's a variable term, here's a constant term, and here's a constant term. Ask yourself, out of 5/4 and 1/4, which one is smaller? 1/4 is obviously smaller than 5/4, so I would subtract 1/4 x from both sides. 5/4 minus 1/4 is 4/4, which is the same thing as 1, so I get just plain old x there. I'm bringing this straight down. I'm bringing this straight down. And now I would subtract 6 from both sides, and I get that x is equal to negative 8. Okay, so 5/4, I'm checking the work now, times negative 8 plus 6, does that equal 1/4 times negative 8 minus 2? This is one I can do pretty fast in my head as far as fractions go. That last one really wasn't. I mean, I could, but it would take me some scribbling on paper. This one goes pretty fast because 4 goes into 8 evenly. And so 4 will go into there once. So 5 times negative 2 is negative 10. 4 will go in there once. So I've got negative 2 minus 2. Negative 10 plus 6 is negative 4. Negative 2 minus 2 is negative 4. So yep, that's my answer. All right, so like I've been saying all along, pick your side that you want your variables to be on. Pick your side that you want your constants to be on. Here's variable term, constant term, constant term. And I always look at my smaller variable term. My smaller variable term this time is 5.4. So I'm going to subtract 5.4x from both sides. And I'm going to bring this straight down. Bring that straight down. Don't forget the sign in front of it. Subtract 4 from both sides. I get 2.4x is equal to negative 12. Now I'm going to divide both sides by 2.4. And again, because I tend to do math terribly in my head, I would grab my calculator and do negative 12 divided by 2.4, and I get negative 5. And so to check my work, I would do 7.8 times negative 5 plus 4. Does that equal 5.4 times negative 5 minus 8? And this is one of those I would truly type into the calculator. So 7.8 times negative 5 plus 4, and here's what I get. I get negative 35. I'm really hoping I get negative 35 on the other side too. So 5.4 times negative 5 minus 8, and I get negative 35. So yep, that is for sure my answer. All right, so that's it for this video. If you have any questions, let me know.